Alrighty. Hi there. It's good to see you again. All right, we have a deck on. So yeah, I'm gonna continue. So I hope most of you were on the Henrik talk about TLS notary. I'm gonna extend on the things he was talking about, and we're gonna talk about web proofs, which is more general idea that TLS notary is implementing. And I wanna just mention that we're working on a 3-part report on verifiable data, and the web proof's gonna be the first part, then we're gonna talk about email proofs, and then we're gonna talk about on-chain proofs. So that's coming soon. The first part is coming this month. So if you would like to be notified when it comes out, you can leave your mail under the link or scan the QR code to get there and leave your mail. So we're gonna go in detail about what the web proofs are, how we believe they're gonna change the blockchain and the wider, the Ethereum and the wider blockchain ecosystem. So yeah, stay tuned. So I'm gonna talk specifically about the web proofs in the context of blockchain. So the Henrik talk was TLS notary, how it works, but now we're gonna try to connect it to the blockchain. And we're gonna start with some use cases. I'm gonna give you some examples to make it really something tangible, and we're gonna look a little bit under the hood. We ain't gonna redo the Henrik talk, don't worry, Henrik. And then we're gonna dive into different security models. What are the consequences of getting those proofs onto the blockchain? And then if we have time, then we can dive into protocol designer consideration, other protocol designer consideration than security model. But I would like to start with emphasizing the importance of web proofs, because if you think about it, where is the Ethereum today? Or again, Ethereum is my favorite blockchain. You can extend this to your favorite blockchain, and we're in the best place ever. The blockchain is legal suddenly. It was always this gray area. Now we have ETFs, we have MiCA in Europe. It's scalable. I remember just a few years ago, it was just, we're talking about scalability again. Nobody done it. It just doesn't work, you know. And now with L2s finally maturing, it seems like, yeah, we're almost there. Like, we have some work to do because all those L2s are not as secure today as we wish they were, but that's probably 1-2 years away. And it's more usable. We have better wallets than before. We have things that, you know, we can design transaction with our fingerprints. We can do all this great stuff. We don't need to know about fees, and all this stuff is slowly going away. But the feeling is something is still missing. Like the blockchain is still this, you know, there are important usages of the blockchain, like, you know, speculation is one of them, NFTs, DeFi, international transfers are a big thing, but it feels the potential is still not realized. And it seems we're lacking the mainstream use case. And I believe, and many people believe, that the reason is the isolation of the blockchain. If you think about the internet, if you think about Web2, it's so strongly intertwined with our lives. We watch movies on the internet, we shop on the internet, we order our Uber on the internet. But when we go into this Web3 world, it's suddenly very, you know, full of anons, and you need to bootstrap your new identity and figure out what to do with that. So the big question for me for several years now was, how do we connect one to the other? And this is where verifiable data comes in. This is where web proofs come in. And the big question one might want to ask, can we really solve the problem with even more technology and even more cryptography? And I think the answer is yes, we can. All right. So verifiable data, 3 different types. We talk about them, I talked about it already, so let's jump straight into the web proofs. So I'm gonna start with examples to make it a little bit more closer to real life. So perhaps the strongest connection today between the blockchain and the real world is real world assets. So we see growth of various tokens that represent real world assets. That could be many different things. That can be just stable coins that represents something that is backed in the bank by fiat currency. But that could be really any securities. It could be shares of the company, stocks of the company. It could be physical objects. It could be real estate. There are companies now that tokenize yachts. So, and it's growing fast. It's the fastest growing subspace of blockchain. But the problem is, a lot of those are not really, like, you just need to trust. We're losing all that permissionlessness. We're losing all this trustlessness assumptions for real assets. How can we improve on that? So with web proofs, you can say, I want to issue a token, right? And that represents your favorite security or real-world item. I'm going to call it Quackles, my tokens. And before I'm able to hit the submit button and issue a transaction, I need to log into my bank. And I need to go to the bank. And there is this plugin in the browser you can see on your right side. And it kind of guides me to the right screen. And then I click, it says the total balance is $2 million. I hit generate proof. Boom. And it takes a little bit. I go back to the application. The proof is already verified. And now I can submit transaction together with the proof, saying, OK, you can issue 2 million Quackles or whatever is the item or token. Obviously, someone can have $2 million today, issue a token, and disappear and make a transfer tomorrow. So we're going to need some kind of health checks, say daily, quarterly, whatever, balance sheet checks. That might vary a lot, what it is exactly, depending on what kind of real-world assets I want to issue. And it's never going to be fully permissionless and trustless, but we can get it to the trust minimized place, which is what we want to do. And another example, and this is interesting because kind of real-world asset already exists, but we believe there's going to be a new category of product, a new business model archetype created within a year or two that's going to be called Web2 Web3 markets. There is a great company, ZK-P2P, that already was mentioned in the Henrik presentation, that is innovating. And Web2 Web3 market is a market that gets settled on Web3, and you trade things on the in the Web2 world, or maybe things in the Web2 world in exchange for the things in the Web3 world. In case of first experiment so that could be like things like, again, that could be securities. Maybe you want to trade your shares in the company, maybe your unvested or vested shares, or maybe you want to trade like virtual items, like game items. But in case of ZK-P2P, it was an on-ramp, so it allows you to change fiat currency for the for the cryptocurrency. And again, it's very similar. You want to exchange $200 for 200 USDC. You pick your bank. You hit swap. You going off to the bank, generate a proof using this sexy plugin of ours, and boom, transaction confirmed, and you receive 200 USDC. And you can claim it. So those are two examples. There seems to be explosion of ideas. Last week there was, I think, at least 3 different tweets from 3 different people, Vitalik included, talking about different ideas. So it's coming. It seems we're going to have a lot of more of those. So just a quick remark. How do we fetch this data? We need to log into the bank. You need to log into the game. You need to log into all those different places. So the web plugin demonstrated by Henrik is one way to go. And I think the nice thing about the plugin is we're already successful as a broader blockchain community in installing plugins into user browsers. So that seems like a reasonable way to go. I believe eventually we're going to merge plugins into wallets as the technology going to mature. And there's a little bit of standardization work to do in the meantime. I'm going to jump to the third one in my presentation, which is a server. I talk about the health check. I think that's going to be the enterprise, the B2B market. They're going to be looking more at the server. The least bullish, I think I'm about the mobile, because we didn't see any successful companies building either mobile browser plugins or applications that ask you to log in inside their application into different applications, so we'll see how the mobile goes. But this is the third option. All right, so under the hood, fasten your seatbelts. Are you ready? This is gonna be fast because Henrik was already talking about it, so I hope you already know. This is a TLS connection. We agree on the naming. I think the transcript is the information being exchanged from the one side to the other. And pretty much every single data somewhere in the world is behind some TLS connection, an encrypted connection. Whether it's HTTPS, and you know that S stands in HTTPS for TLS, and so on and so forth. Like almost every encryption today is encrypted, and almost every encrypted connection is TLS connection. So the web proofs in a nutshell is this idea that the client can take a transcript and take the transcript to the verifier in a way that verifier can be assured that this is really the transcript that happened from the connection between client and server, right? And TLS notary solves it, and this is pretty much how almost all web proofs work. It solves it in a way by introducing a notary. Notary is joining a client and connecting to the server, so they have this the kind of MPC algorithm having, and they all kind of taking half of the responsibility for making things happen, and only together they can make the connection happen, and only with the data from both client and notary, verifier can reproduce the transcript and hence be convinced that this is really the content of such a connection. And this is really where our story starts, is how do we transfer that information to the blockchain, right? So this is kind of where TLS notary story ends, and this is our big question as a community. How do we make those real-world assets, how do we make those Web2, Web3 market work by transferring this confidence of verifier to the blockchain? And that's a big question. And one first idea that should come to everybody's mind, why don't we just run verifier on the blockchain? Well, unfortunately, a verifier is pretty computational intensive thing, and even with the cheapest old tools and much better VMs than EVMs, that probably would be not feasible. So there is 6 ideas how to solve. There are 6 different security models I want to discuss today, or at least 4 I want to discuss in deep, and 2 more I want to advertise. So first is a naive approach where we trust the verifier or notary. It's kind of the naming thing, which one is which in this scenario. But we simply ask the verifier, hey, verifier, can you sign it for me and put it on the blockchain? The problem is verifier is a single point of failure, and he can get malicious, he can get hacked. So that's not a very good idea. So this is, by the way, important notion. Also statement about where we are as a subspace of the blockchain. Everybody is using that today, right? So wherever you go to ZK-P2P or any other, this is what we're using today. This is not the final solution. This is what we build prototypes with. So keep that in mind before sending millions of dollars with a TLS notary to someone. Yeah. So, so the first idea is, how about we prove the verifier in the ZK prover? And then when we put that in the ZK prover, we already get some interesting security properties. So now the verifier needs to provide a transcript and a proof. The nice thing about this solution is that we can add computations, right? So when we're getting this server response, let's say it's a JSON or maybe in the future HTML, it's a little bit too slow today for the HTML, but could be very well ready for HTML in a few months. So how do we parse that and get all the information we want? And again, we can do it on-chain, but it's computationally heavy, like even a small JSON is like a kilobyte, sized in kilobytes. A little bit a lot to parse on-chain, but if you do it in the ZK, then you can just add these computations, which are pretty simple and compiled onto verification. So that's already have a really nice security properties, because and I'm going to start with the second point here, is for the client, for the people who are using the protocols based on web proofs, it's already multi-sig 2 out of 2, right? So it needs to be, in case of real-world assets, it needs to be asset manager and a notary, then design on something, right? And they cannot do it without themselves, right? So that's already so much better than multi-sig one of one, right? But the real big increase in security is on the client side. So the client, talking about HTTP clients, so real-world asset again, right? Because now the notary cannot do anything without the client, right? So imagine you run a notary and you have a bunch of clients and it gets hacked one day, you know, and you're not responsible for all them losing money. So that's a really big security improvement. And one thing is important. For that to work, we need to know who the client is, right? So if we are talking in the TLS, if we're talking about the asset manager case, well, the asset managers, we know who they are, right? We know what bank account they're gonna log in. We know what their address is on-chain, right? It's a little bit different for the cases like Web2, Web3 markets, because in that case, well, we don't know who the client is, so the malicious notary or hacked notary can just spawn a bunch of clients and drain the protocol, right? So it's really important protocol design and consideration. Yeah, so it's a very reasonable level of security for example, real-world asset stuff. A little bit more tricky for that Web2, Web3 markets. Then everybody talks about secure enclaves and trusted execution environments. And if I could get just one Bitcoin every time someone talks to me about it, I would have a lot of Bitcoins. So TEs are interesting, and they can improve security significantly, but not in a way that most people understand. So the first and most important assumption on TLS notary or web proofs in general is it's secure because client can do nothing without notary, and notary cannot do anything without the client, right? So it doesn't increase the security in a sense that a notary colluding with a client or spawning its own client or hacked notary can spawn their own clients or collude with clients. It doesn't solve that problem, but it makes notary so much harder to hack. So that's an important thing, and there are two variants of that. We can run trusted execution environment on notary and verifier. So yeah, about TEs, everybody said, a lot of people say use TEs, but they get hacked all the time. And here is an interesting argument I heard a few times before, but not a single TE got hacked in a way that leaked the private key, hardware private key, the designs, right? So that should be good. That doesn't really matter in this case. Because the only thing we care about is they don't share the secrets, right? So not the hardware key is important, but the content of what's on the server or inside the enclave in this case, right? And there are some very sophisticated and expensive techniques for getting the private key if someone insists on talking about it. But all in all, it's a very expensive attack. It's available to big companies with, you know, the cost of such an attack is in hundreds of thousands of dollars, and maybe to the state actors as well. So not impossible, but not your script kiddie kind of thing. Yeah. Yeah. So that was variant 1, but variant 2 is interesting because you can kind of combine ZK with TE, and now ZK is responsible for making sure that client and notary, if they don't collude, then the result is okay, the result is verified, and TE is just making getting notary hacked very, very, very difficult. Yeah, so that could be a reasonable for, and I think this is a good moment to introduce the notion of black swan event. So when you design your protocol based on TLS notary, you don't want to have a black swan event that kind of withdraws all the money from your protocols based on web proof. So that could be like 1,000 users, each coming with their own web proof and withdrawing a little bit of money. That could all happen in a single block or in a few blocks, one after another. And so that could be a single black swan event. So that's still tricky for that. But if your protocol doesn't have a black swan event, that could be very reasonable level of security. Then there is this idea to increase the number of notaries. So why not instead of one notary, we have two notaries? So that's technically possible. I don't think it would be technically possible to increase number of notaries to 3, because the overhead of notary is already 1,000 times, roughly 3 orders of magnitude. So when you exchange a kilobyte of data between the client and the server, that translates to roughly a megabyte of data between the notary and the client. So the TLS notary is working hard to push it down, and they believe they can push it down 1 order of magnitude. When that happens, you can exchange the main 2PC, 2 multi-party protocol into 3-party protocol, and introduce a notary, but that's going to bump again the overhead. So we're probably not able to do more than that. But the interesting thing is we're basically bumping multi-sig 2 out of 2 into 3 out of 3. Well, that requires major changes to the protocol, so that's maybe a year or 2 years ahead of us. But that's really interesting idea, especially if we combine it with TEs. Like this is like attacking that would means having hacked into 2 TEs simultaneously, colluding with the client. Like that's getting really difficult. Not impossible, theoretically possible, but yeah, really hard. Good, and so that was the main 4 ideas, algorithmic or hardware-wise. And now we can talk a little bit, and I'm gonna just not try to explain the whole thing. Gonna give you just a brief introduction of some ideas, how we could do it, solve it by crypto economy. And I think the leading team comes with caveats. It's not that easy. Like when you start exploring. Like everybody started exploring, and I know we need the notaries, and they're gonna vote. Yeah. But then this and that, and it gets really complicated really fast. But there are those 2 ideas that seems to be pretty worked out. So this is idea coming from ZK-P2P team that I mentioned already a few times. So if you assume 4 different additional security assumptions, which is incentivized counterparty, which means there's someone else in the system who is incentivized to tell the system that you cheated when you cheated, and he has the same access to the data as you do, right? So that's in the Web2, Web3 markets, that's usually the case because you have, another user of, if you're sending a transfer from bank to bank, from Revolut to Revolut, you have information that you send, and the other person has information that they received, right? Data immutability is an important assumption, which means if I keep querying my bank again and again about my transaction, it's still going to be there, and it's going to be same transaction. So this is a little bit tricky, but because even in the banks, transactions tend to change over time. And trusted notary majority, so we have a network of notaries, and we can trust them. And transaction value clarity, this is kind of optional. But when we know we're trading $100, that we can insure $100 for $100. If we're trading something and we're trading $1 million, but we don't know it's $1 million, and someone gets $100 in return, that's not really solving a problem, right? So the idea is to introduce the network of notaries, and basically it's an optimistic notarization, right? So when you want to notarize something, you just go to a random notary. You can pick yourself. It can be some process to pick that up, but I think you can pick yourself, or randomization is perfectly fine. And then if this incentivized counterparty says, hey, but I did send a transaction, right, or wherever is the opposite information, then you say, okay, I wanna start a dispute, and we're gonna settle, and you go to all the different notaries, and you do a settlement, and then the majority votes, and if the majority says it happened, when the notary didn't believe that happened, the original notary, that's the one that gets slashed, that's the one that pays insurance, and that's where property known as transaction value clarity comes in handy. Good. So the next talk is from Opacity. I ain't gonna talk about their stuff because you should hear it from themselves. But there is one more idea that's gonna be discussed next. So TLS notary and in general web proofs are very nuanced topics, and I hope I convince you a little bit that on the security side, it's not that straightforward, and we don't get perfect answers. We need to mitigate things and get to a reasonable places. There is other consideration. There is a replay attack problem. So if you notarize something, how do we make sure it's not getting reused? So that can be solved by similar means as replay attack in Ethereum. So that has a few different shades. Just want to make sure it's in your head before you start building something. There is anonymity consideration, and TLS notary has this wonderful property that notary doesn't know anything about the content of the transcript, only the verifier does. So maybe one day we're going to be able to run those verifiers on our own machines in the ZK, or in different setups, we're going to be able to run on machines. So we're going to, on our own machines. So that's going to be wonderful for anonymity, because the only thing they're going to get to the blockchain is the result of the computation. So they don't know nothing about the original request, only about the result of computations. And finally, there is still there is a lot of performance improvements that have to happen across the whole stack, starting from MPC algorithm all the way to how do we sell that on the blockchain. And I think that's going to be a long ride, but we get to a place where it's really nice UX, and yeah. So that's another bunch of considerations that we have to keep in mind, that it takes, whatever, 30 seconds to notarize, another some amount of times to calculate ZK if you do calculate ZK. So that's something you should think about when designing protocols. Yeah, I think those are my extra slides, so I'm going to skip on them. Yeah, so web proofs are definitely among the most exciting technologies that are being built today, and new exciting use cases are coming. I hope everybody is convinced by now. We need a little bit more time to mature, and it's really important that protocol designers are aware of those security nuances and other nuances that comes with it. So yeah, stay tuned for the report, and stay tuned for what vlayer is going to be role in all of this. And thank you very much for coming to my talk.